I'm going to talk about the method of substitution for solving systems of linear equations. I will assume that you know what systems of linear equations are. If you don't, I would invite you to watch my introductory video. All right? There are two common methods used to solve systems of linear equations. You might wonder why you would want to or need to learn more than one method. One reason is because different methods are convenient for different systems of linear equations. Okay? Let me repeat that. For different systems of linear equations, different methods of solving systems of linear equations will be convenient. And I assume that you always want to use the most convenient method. Okay? So what is the method of substitution? Let's start with an example problem. Suppose you wanted to solve the following system of linear equations. Now, one of the things that makes systems of linear equations difficult to deal with is that you have two equations instead of one. Furthermore, you have two variables, right? What if there was a way that I could eliminate one of the variables? Wouldn't that be helpful? All right, watch this. Because the second equation says that y is equal to x plus 2, that means that everywhere that y appears in the first equation, it'll still be equal if I replace y with x plus 2. Okay, so let me go ahead and do that. So in the first equation, I'm going to replace y with an equivalent expression, namely x plus 2. Okay, now why is that potentially useful? Well, notice that the blue equation now only has one variable. And we know how to solve, or I hope you know how to solve, single equations for a single variable. Okay, I'll go ahead and do that now. So the blue equation can be rewritten as follows. And that's equivalent to the equation 5x equals 5. I subtracted 4 from both sides and I combined the 3x and the 2x terms. Now if I divide both sides by 5, I see that x is equal to 1. Okay? So I've got one variable. Now how do I find the second variable? Well, doesn't the second equation, the y equals x plus 2, doesn't that give us the value of y in terms of the value of x? So let's use that equation. Now I'm going to replace the x with something. I'm going to replace the x with 1. So y is equal to 1 plus 2. So that means 3. So lo and behold, I found the solution to this system of linear equations. Okay? So to recap, what I did was I eliminated one of the two variables in one of the equations by replacing it with an equivalent expression in the other variable. Okay, I replaced y in the first equation with an expression in x. Okay? Let's do another example. Suppose I wanted to solve this system of linear equations. So in the last example, I replaced y with an expression in x. For this example, I'm going to replace x with an expression in y. So the first equation, I'm going to rewrite it as follows. 2 times the equivalent expression, so 2 times 3y minus 2 minus 4y equals 7. Now I have a single equation in a single variable, namely y, and so I could now solve for y. So 6y minus 4 minus 4y equals 7. So adding 4 to both sides and combining the two terms containing y, I get 2y equals 11. So y is equal to 11 over 2. I determined that by dividing both sides by 2. Now I can solve for x by replacing y with 11 over 2 in the second black equation. So that will give x is equal to 3 times 11 over 2 minus 2, or 33 over 2 minus 2. And let me rewrite the 2 as 4 over 2 so that I have a common denominator. So that's equal to 29 over 2. So packaging our answer, the solution to the system of linear equations is 29 over 2, comma 11 over 2. Okay? Now I would like you to try to use the method of substitution to solve a system of linear equations. Would you please try to solve the following problem? Find the values of x and y that satisfy both of those linear equations simultaneously. All right, so pause the video and do that now, please. All right, so I'll go ahead and do it as well. So we need to solve for either x or y in terms of the other variable. So in the first equation, let me subtract 3x from both sides. So I have y is equal to 12 minus 3x if I do that, right? Now I have an expression in x that I can substitute for y in the second equation. So the second equation can be rewritten 2x plus 5 times 12 minus 3x equals 8. And now I can solve for x, right? So 2x plus 60 minus 15x equals 8. So what I did was I distributed the 5. And now I can combine the two terms with x to get minus 13x. And then I can subtract 60 from both sides. So I'll have minus 52 on the other side. And if I divide both sides by negative 13, I will get x is equal to 4. Now let's replace x with 4 in the top red equation. So that will give y is equal to 12 minus 3 times 4, or 12 minus 12, which equals 0. Right? So packaging our answer, the solution to this system is 4, 0. All right? Now, would you please do this example? (8x plus 2y equals 6). And y is equal to 3 minus 4x. So again, pause the video if you like and try to solve this system of linear equations using the method of substitution. All right, so I'll go ahead and do it as well. So we already have y in terms of an expression in x. So let me replace y with, in the first equation, with that equivalent expression. So that will give 8x plus 2 times 3 minus 4x, and that's equal to 6. So I can solve that red equation. 8x plus 6 minus 8x equals 6. Now I can combine the two terms with x and subtract 6 from both sides, and if I do that, I get 0 equals 0. All right, what just happened? Well, for what values of x does 0 equal 0? I think you would agree that that's true for all values of x. So this is a special situation. All values of x satisfy this linear equation. What about the corresponding values of y? Well, whatever the x value is, the y value has to be equal to 3 minus 4x. That's what the second black equation says. Okay? So the solution for this system is the set of all points x comma 3 minus 4x, where x is any value. All right, so if this will help you understand what's happening, remember that each black equation corresponds to a line. Okay, so what's going on here is that the corresponding lines are actually the same line. They're one's on top of the other. Okay, how many points do two lines on top of each other have in common? Don't they have all their points in common? Okay, so that's a way to understand what's going on here. All right, would you please solve this problem? So minus 4x plus 2y equals 7, and y equals 2x plus 9. So find the values of x and y that solve both linear equations simultaneously. So pause the video and do that now, please. All right, so I will substitute y in the first equation with the equivalent expression x, 2x plus 9. So the first equation can be equivalently written as minus 4x plus 2 times 2x plus 9 equals 7. So minus 4x plus 4x plus 18 equals 7. Combining the x terms, I get 18 equals 7. Whoa, what just happened? Okay, that's not possible, is it? Okay, so for how many values of x does 18 equal 7? I think you would agree that that's true for no values of x. Okay, so this problem has no solutions. All right, to help you understand what's happening here, again, remember that each black equation corresponds to a line, and it's possible to draw two parallel lines on a plane, right? And two parallel lines never cross, they never intersect. So they have no points in common. So that corresponds to this system, okay? So that's why there's no solutions. So I showed you those two examples because I just wanted you to be aware that you're not always going to have a situation where you have a single point for the answer. Okay? Now, let's do one more example, and I'll just go ahead right now and say that for this example, you will have a single point as a solution. All right, so pause the video and please try to solve this problem. All right, so I'll go ahead and solve it as well. So in the first equation, I will add y and subtract 7 from both sides. So if I do that, I will have 3x minus 7 left on the right side and y on the right side. So 3x minus 7 on the left side and y on the right side. So now I have an expression I can replace y with in the second black equation. So 4x minus 5 times 3x minus 7 equals 2. And I can solve that. 4x minus 15x plus 35 equals 2. Combining the x terms, I get minus 11x. Subtracting 35 from both sides, I get minus 33 on the right side. Dividing both sides by minus 11, I get x equals 3. Now I will substitute 3 for x in the first red equation. Let me make another comment. You can actually use any equation that I've written on the board to solve for y. All right? Try to replace x with 3 in any equation that contains x and y, and solve for y. You will see that for any choice you'll get the same answer. The only reason I'm choosing the first red equation is because it's the most convenient. Why is it the most convenient? Because y is already isolated in that equation. All right, so y equals 3 times 3 minus 7, or 9 minus 7, which gives 2. So the final solution is 3, 2. Okay?